Hi everyone, welcome to Differential Calculus. Today we explore lesson 4.8, Newton's method. This is the coolest way to figure out the root of a function. Number one, Newton's method. Let's take a look at what it is. Let's say that we have a function fx. We have no idea what the root r is. So in order to approximate r, we're gonna pick a number x sub 1 near r. Step 1, pick x1 near root r, and we're gonna use, well, at x1 there's the point right here, x1 fx1. What is going on here is that there is a tangent line. Down here we have x sub 2. We can use the slope of this tangent line to figure out x sub 2. Okay, so we know slope is change in y over change in x. Slope of tangent line is f prime of x sub 1. Change in y is y2 minus y1, but y2 is 0. So 0 minus y sub 1 is f x1 over x2 minus x1. And as you can see, x2 minus x1 is minus fx sub 1 over f prime x sub 1. So x sub 2 is x sub 1 minus f x sub 1 over f prime x sub 1. What we do next here is we use the same argument. So at x sub 2, there's the point on the curve, x sub 2, fx sub 2. And we're gonna get the tangent line through this point, 3, right here. It's very near R. And in order to get x sub 3, we use the same argument. Use slope of tangent line at x2 fx2 to find x sub 3. X sub 3 using the same argument, we have a x sub 3 to be x2 minus fx2 over f prime x sub 2. And if we keep going, eventually we're gonna get a recursive formula. X sub n plus 1 equal xn minus fx sub n over f prime x sub n. And this is the Newton method. It works well as long as the derivative of x sub n does not equal to 0 or it's not near 0. Let's take a look at some application. First application, 2 application in numerical approximation. Example, approximate two to the power 1 sit correctly to 8 decimal places. Wow, it's a huge task here. Well, let 2 to the power 1 6 be a root of a function then x equal 2 to the power 1 6. So x to the 6 is 2 and x to the 6 minus 2 is equal to 0. That means the function is x to the 6 minus 2. So now we have to figure the derivative and use the Newton method of. Now f prime x is 6x to the 5. Newton method. We have x n plus 1 equal x sub n minus fxn over f prime x sub n, which is x sub n minus, well, x sub n to the power 6 minus 2 over 6 x sub n to the power 5. And now it's just going to be the substitution. Let's do the sub correctly here. Well, 2 to the power 1 of 6 is near 1, so we're going to pick x sub 1 to be near near 2 to the power 1 of 6, which is around 1. So pick x sub 1 to be 1. Now we're going to run through the Newton approximation. X sub 2 is going to be x sub 1 minus x sub 1 to the power 6 minus 2 over 6 x sub 1 to the power 5, which is 1 minus 1 to the power 6 minus 2 over 6 times 1 to the power 5. Using a calculator, we have a 1.1666 1, 2, 3, 4, 5, 6. You see how many decimal are there? 1, 2, 3, 4, 5, 6, 7, 8 decimal. Okay. X sub 3, x sub 2 minus x sub 2 to the power 6 minus 2 over 6 x sub 2 to the power 5. And that would be 1.166667 minus 1.166667 to the power 6 minus 2 over 6 times 1.166667 to the power 5, and that is 1.1. Yeah, this should be approximately equal to 1.1264438. Similarly, x sub 4 is approximately 1.122497007. X sub 5 is approximately 1.1224605. X sub 6 is approximately 1.122460205. We have a repetition of 8 decimal places, so this is where we stop. And it is the approximation very cool. It's just a little tedious to do this. That is why it is good to write out a program either in C++ or in Python and let the program run through.